Hi, welcome to our math. Today I'm doing a series of videos on functions and specifically composition of functions. So what does it mean to be a composition of functions? First of all, let's look at two functions. Let's say that I have f of x equals 2x plus 3 and g of x equals 4x minus 1. Now, probably in the past, you have seen taking these two functions and adding them, subtracting, multiplying, and dividing. Those are the common things we do. We add, subtract, multiply, and divide functions. Let's take it back a little bit further. When you first learned function notation, turning y equals 2x plus 3 into f of x equals 2x plus 3, the very next step was to start changing that input into different numbers. So for instance, you may have done f of 4 equals 2 times 4 plus 3. So f of 4, 8 plus 3 is 11. That's probably something that you did in your past. Or maybe you did f of negative 5. So 2 times negative 5 plus 3, f of negative 5, let's see, negative 10 plus 3 is negative 7. So this is something that you may have done in the past. Potentially, you played around with putting in other variables. So maybe you did something like a little more advanced, f of y squared, where you turned x into y squared. 2 times y squared plus 3. This is just a variable shift, adding a little spice, turning your linear into a parabolic. But we could take this even further. What if I turned my x, instead of into y squared, what if I said f of 4x minus 1? So now I have 2 times 4x minus 1 plus 3. Notice in every single case, I am just changing this x into whatever is in my input spot. So this case, it's a binomial, but it's still doing the exact same thing, replacing that x, that input, with whatever I have in my input spot. So I'm going to take an actual extra step here. I'm going to distribute 8x minus 2 plus 3. So now I have f of 4x minus 1 equals 8x plus 1. All right, not too bad. But if we notice, 4x minus 1 is g of x. So what I really did was I found f of g of x. I put this function into that function, and that's what a composition is it's finding f of g of x. And we can actually smooth this out even more and say f of g of x. I could do it the other way around. I could say find g of f of x. And if I say g of f of x, g of f of x, that's saying take g of x and put f of x into it. It's saying put this function, 2x plus 3, into the input of this function. So take g and instead of having these x's, replace it with what f of x equals. Well, what f of x equals is 2x plus 3. So I'm going to put the 2x plus 3 here. I'm going to put the 2x plus 3 here. That's what the composition is. It says put a function in for the input of another function. Now I'm going to distribute. So g of f of x equals 8x plus 12 minus 1. G of f of x equals 8x plus 11. Now you know what a composition is. I will add, as a little bonus to the video, I found f of g of x. I found g of f of x. You can actually put a function into itself. I could have found f of x. So this would be 2 times 2x plus 3 plus 3. I just put the function itself into itself. Sounds very weird. So f of x, 4x plus 6 plus 3. Again, if you want to see it the other way, I just am finding f of x is 4x plus 9. So there's lots of flexibility here, but a composition of functions is when you put one function into the input of another function. All right, I hope you enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thanks.